Okay, last video on the wave function. So we read the question and give it a pause, and then we'll go through it. So first thing I'll be doing is writing out my wave function, and it's told me which function to use. As I've said before, you could use any one you like. This is the one that I would pick to use if I was asked. Now you're given these expansions, so make sure you don't make a mistake here. Remember, you're changing the sign for the cos one. And I'm just going to rewrite it. I'm going to move my cos alpha to the front. So I'm not switching alpha and t, make that very clear. I am moving the alphas to the front. So if you get a sine t cos alpha, the cos alpha goes to the front. We're not switching these, we're actually physically moving the entire cos alpha to the front and the sine alpha to the front, so that I can now equate my function. Oh, it's a bit different, isn't it? Usually we were told what our function is, but this is saying two sound sources produce two waves. An investigation into the addition of these waves shows this graph. So what does that mean? Well, it means that sine t plus root 3 cos t is going to be equal to our function. So this has to equal this. Now, this is a great one because usually it's been in the correct order. Now, if I look at it, oh, wait a minute, that doesn't equal this. That equals that. So what do? Well, we just flip it around. Okay. So instead of putting the sine first, this is where my computer starts to fail me. Instead of putting the sine first, I'm going to write it out as cos first. So root 3 cos t plus sine t. And obviously, if it's sine t, it's just one sine t. Yeah. So as we said before, visualizing is really important for this. This wave plus this wave equals this wave. So I've just broken the wave function out using the addition formula. And now I'm saying, well, this has to equal this. And that's why I wrote them on top of each other so I can more easily equate them. And all I did was, instead of writing sine t plus that, I wrote cos t plus sine t. Because now I can say, well, if you look, this has to be the same as root 3. And this has to be the same as 1. Fantastic. So now, I'll just put my little notes here. Expand. That's me equated. And now, step 3, I'm going to do my alpha. So I'm going to say that k sine alpha is equal to 1. And k cos alpha is root 3, which means that tan alpha has to be sine over cos, so it's 1 over root 3. And this wants it in radians. So alpha is going to be 30 degrees in radians. So shift tan answer, so pi over 6, yeah. Pi over 6. And we should be doing our cast diagram at this point, but come on, we should know this now. Positive, 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 there's no changes. Our sine is positive here, cos is positive here, tan is positive here. So looking for the 3 ticks, it's that one. Again, if this was a negative, say one of these came out as negative, say the sine was negative, which would then make the tan negative, don't forget, you're always doing inverse tan of the positive version. You never put in inverse tan of a negative. You always want inverse of sine, cos, or tan as the positive, and then you use this to get your final answer. Okay, so we're happy with that. The next bit is k, and k is equal to 1 squared plus root 3 squared square rooted. There's a breakdown of that. If you square them, the k squareds equal, you can take out the, yeah, we've talked about it before, but anyway, root 4, which will be 2. But you don't need to do that. You basically just have to remember it looks like Pythagoras, and that's you. So our final answer means we've got a wave of 2, and this was a cos x take away 30 degrees pi over 6. Okay, so that's me got my wave function. Now the question's asking, calculate P. where is P at? Calculate the coordinate for P, hence calculate the value of the T coordinate. So we don't need to work out, in fact, we know that P is 1.2, don't need to work out the Y value for that, we know it's 1.2. How would we possibly work out the T value or the X value? Well, all we need to do is say, okay, well, our wave function is 2 cos. Doesn't look like 2. That's a 21. Yeah, I definitely feel as I get more tired, the computer gets more tired. Stop doing stuff. So we know our wave function is this. So I'm saying, well, when is y 1.2? So I just substitute in my y is 1.2. And then we're going to solve. So see, so far, the only tricky thing I think is putting those two together. And there was a slight rearrange here, just moving them around left and right, which we've not done. But everything else, exactly the same, isn't it? So 1.2 divided by 2. Pi over 6. So 1.2, and if I do my inverse cos, that's giving me a 0.927. So that'll be equal to x take away pi over 6. If I do my diagram, I know I'm going to be in quadrant 1, because cos is positive, this is a positive ratio, and quadrant 4. So there's quadrant 1, and there's quadrant 4. And this is just my x, this is 2 pi take away x, this would be pi plus x, pi take away x, remember that, that's just in radians now. So I've got 0.927, that's fine. And I've got 2 pi take away 0.927 is equal to x take away pi over 6. And then you just rearrange them, we're just going to add on pi over 6. And then here we'll do this and add on pi over 6. So 0.927 plus pi over 6. So my two answers here are 1.45. And over here, I've got 2 times pi. And I'm going to add on pi over 6. So it gives me 5.87. I'll round that off and say 5.880. So, what's my answer though? That's 2 answers. I'm looking for 1 answer. Now, what I've actually done, again, this is where the visualization comes in, is I've said, where is this function equal to 1.2? So 1.2 is this line here, y is equal to 1.2. Yeah? So I've worked out this, and I've worked out this. So I don't want my quadrant 1 answer, my lowest answer. I want the next answer that's close to 2 pi. So 2 pi is about 6.3, so very close to that. Okay, so that's the 1.4, so I don't want that answer. I would then say, what's the question asking? The t coordinate, yeah, so t is equal to 5.88. 0, or I could, the answer says 5.9, let's round it off that way. So, you wouldn't have got a mark if you hadn't have then gone on to answer the question. But most of your marks are available for following the standard procedure. Getting your wave function, there's 4 marks in there. And just thinking, what's the question asking? When is y 1.4? Just substituting, sorry, 1.2, substituting your 1.2. So look, that's been 8 videos. I think we've done 8 or 9. We have gone through, I would say, the most common questions, which is coming up with your wave function and solving it for an arbitrary number. So this one was asking us to solve it for, was it 3, this one's asking 5.5, so that's fine. And then we're asked about solving it for max and min. So we do a wave function, and then we say, okay, well, what's the max of this wave function? That's root 5. But we want to know the max of this function. Well, how do you get from this function to here? We times that by 3, so I have to times that by 3, and then you solve. And this one we didn't use our cast diagram, we just kind of used a visual to get the final answer. And then we had some contextualized questions where it just sounded a bit more complicated, or there were graphs thrown in. But in reality, each time, if you think of what you're doing, you've got this one wave, you're solving for y, It's very similar each way through. Okay, so look, best of luck, and I really hope that that was helpful.